Yes?
Hi, are you Dr. McCourse, the nutritionist?
Actually, I am both a dietitian and a nutritionist.
Dr. McCourse, I am really interested in artificial sweeteners, and I don't know if they are good or bad for you. I've read many different articles. Do you have any knowledge that you can share with me?
I specialized in both, and so I am more than qualified than most to answer your question. So sucrose and sucralose, they are different molecules, yet they are both extremely similar, except there's one modification in the sucralose structure which makes it different from sucrose. I actually have a 3D molecule right here of sucralose. I'd be happy to show you, just give me 1 second. This is my 3D structure of sucralose right here. This is a 3D visualization of what sucralose looks like as a molecule. And let me tell you what each one of these means. First off, each of the balls is representing an atom. The balls with the orange stripes represent oxygen. The smallest balls with the yellow stripes represent hydrogens, which usually are not counted because they are usually a given, but I am showing them here. The purple stripes are carbons, and the green stripes are chlorides. And lastly, these sticks that you can see are connecting each one of these balls are representing bonds. When there's one stick, that is a single bond, but also called a sigma bond. And when there are two, that is a double bond, but can also be called a pi bond. But in the sucrose molecule, there are only sigma bonds. And to be exact, there are 43 sigma bonds. Sucralose is made through a multi-step process. Essentially, you start out with sugar, and then they remove the 3 of the OH bonds. In the sucralose molecule, there are certain forces that are shown in it. One of the forces that is shown in it is hydrogen bonding. A hydrogen bond is when hydrogen forms a bond with FON, F-O-N, fluorine, oxygen, or nitrogen. That is called a hydrogen bond. For example, there are the OH bonds, which are oxygen and hydrogen. There are also dipole-dipole forces and London dispersion forces. I find that when talking about polarity, it's very easy to understand when you compare it to water. So, for example, water is considered a very polar solution. Water has a melting point of 0 degrees Celsius and a boiling point of 100 degrees Celsius. Water has very strong hydrogen bonds, which are relatively strong intermolecular forces. It would take a large sum of kinetic energy to break apart these bonds and to form water at a liquid state into gas, assuming that it's at room temperature. Now, when talking about sucralose, the melting point of sucralose is 125 degrees Celsius, and its boiling point is approximately 670 degrees Celsius. Now, when comparing this to water, that is a significant increase, which really shows that sucralose is a very polar substance. Secondly, one great use for sucralose is in cooking, and it is very commonly used. Because of its high melting and boiling point, it will not when you cook. Usually when you're cooking sugary things, it is usually in the oven or possibly on the stove. And since it has such a high melting and boiling point, it is not likely that you will cook at that temperature and that it will melt or boil. And secondly, it is very commonly used in to preserve packaged foods. For example, granola bars, really anything that comes packaged and is not fresh. This is because since it has such a high melting point and boiling point, it is usually good in many conditions, which makes its shelf life longer than other artificial sweeteners or just other sweeteners in general, such as high fructose corn syrup. So there has been much debate on whether sucralose is good or not. Going back to your original question. Essentially, sucralose, because of its chlorine atoms and its structure, the way that when it goes into your body does not absorb it and recognize it as carbohydrates, and so it does not metabolize it. The reason that a lot of people are nervous about using it is that they see that it is made with chlorine, and many people get frightened by the fact that they are eating chlorine when in fact it is in some of the most common foods that people eat. Take tomatoes or table salt, which is NaCl. I do not believe people should be scared about using sucralose because for 20 years the FDA and the company that originally produced sucralose has put it through many tests on both animals, humans, people that have different health conditions, and it has never in the long term produced any harmful side effects that they have been able to tell. Overall, I do not believe one should be scared by them, since considering that there is no scientific evidence that it can cause long-term damage to your body.
That's awesome, Dr. McCorris. Thank you so much.